Alrighty guys, so this is section 5.4 and this is the sum and difference formulas, right, for which you'll get to use a formula sheet on your test. So we have the sum or difference for the sine function. So if it's u plus v, we get sine, cosine plus cosine sine. If it's the sine of u minus v, it's sine, cosine minus cosine sine. Okay? But the cosine is backwards. If I have the cosine of u plus v, it's cosine, cosine minus sine, sine. And if I have the cosine of u minus v, then it's cosine, cosine plus sine, sine. Same thing with the tangent. So the tangent and the cosine have that sort of backwardsness, but the tangent has it on the bottom only. If I have the tangent of u plus v, then on top it's going to be tan u plus tan v, but on the bottom it's going to be 1 minus tan u times tan v. And if we have tangent of u minus v, be tan u minus tan v over 1 plus tan u tan v. Right? So again, you'll have the formula sheet, so you'll be probably okay with that. So one thing we want to use this for is to evaluate trig functions. So you're going to be given maybe a weird angle, like cosine of 75 degrees, and you're going to ask to find it exactly without a calculator. So again, I'm going to remind you to use familiar angles. Somehow you want to break this weird angle up into things that you know from your unit circle. So what I could think of is 30 plus 45. Why? Because we know what the cosine of 30 and the cosine of 45 are, so that's going to make our life easy. So I'm going to say the cosine of 75 degrees can be rewritten as the cosine of 30 plus 45, or in my case I put 45 first plus 30. It doesn't matter how you put them in there. Well, according to the sum formula for the cosine, it's going to be cosine 45, cosine 30, minus sine 45, sine 30. And then from the unit circle, I know the cosine of 45 is root 2 over 2 times cosine of 30, which is root 3 over 2. Bring down the minus. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So if I multiply these, I get root 6 over 4 minus root 2 over 4, and we can write it like that, root 6 minus root 2 over 4, because the denominators are common, they're the same. In the next one here, they're giving us cosine of 120 plus 45. Now you might think, well, I don't know what 120 is. Yes, you do. You can go back to your unit circle, and there's 120 degrees, okay? And it's just, you know, pi over 3. If you want, you can convert that. You can multiply it by pi over 180 and change it to radians if you're more familiar with that. But anyway, you can find the cosine. It's negative 1/2. So again, I want to be careful of what quadrant I am. This tells me I'm in quadrant 2. This tells me I'm in quadrant 1. So this one here with the cosine, I got to make sure I put a negative on the values for this angle here. So the cosine formula for the sum again is cos 120, cos 45, minus sine 120, sine 45. And then I go ahead and I plug in or substitute the appropriate values. I get negative root 2 over 4, positive root 6 over 4, and I can rewrite that as one fraction as negative 2 minus root 6 over 4. Now, I want to bring this up again. I did it in class, but I want you to be really careful here. Let me bring this up a little bit. This is not the same as this. Okay, so what you're looking for is a sine, a cosine, a tangent with parentheses and the sum or difference of two angles inside those parentheses. Here they're saying, you know, what is the sine of 3 pi over 4? Well, I don't know, I forget. Well, let me look at my unit circle. Here's 3 pi over 4, right? What was that again, the sine? Yeah, the sine is a positive root 2 over 2. It's the y coordinate, right? So I can plug that in. And then the sine of 5 pi over 6, well, I go back to my unit circle and I see the sine of 5 pi over 6, again we're in quadrant 2, is 1/2. So I can replace that with 1/2. And now I can add these together because thankfully their denominators are the same and write it as root 2 plus 1 over 2. So just be careful. This is not the same as that. the sum or difference formulas, you're going to have them in parentheses like that, all right? Or they're going to give you some weird angle like this that you have to break it up and put it in parentheses like that. So be very careful with that. Here's another one in radians. Sine of pi over 2 plus pi over 3. Well, that's sine, cosine, plus, that stays the same with the sine, cosine, sine, right? And from the values of our, on the unit circle, the values of those angles on the unit circle, the sine of pi over 2 is 1, cosine of pi over 3 is a half, cosine of pi over 2 is 0, and at that point, if you have 0 right away, just stop, because that times anything is going to go away. So what you really have is a half, and you're done. Now the tangent problems are a little more tricky because you've got a denominator, you got a complex fraction, and most kids hate those. So you're going to have to be very patient and very careful with these. We have the tangent of pi over 6 plus pi over 4. I made a mistake. I see my mistake right here. Dang, dang, and double dang. Okay, so I'm not going to show you that. I'm going to rewrite this. A fresh sheet of paper. We've got the tangent of pi over 6 plus pi over 4. Alright, so what I know from the formula is that this is the tangent of pi over 6 plus the tangent of pi over 4 divided by 1 minus the tangent of pi over 6 times the tangent of pi over 4. Right? And the tangent of pi over 6, again, you know, from your unit circle, is root 3 over 3. So I've got root 3 over 3 plus the tangent of pi over 4 is 1. Okay, now that's just my numerator that I worked on. So I'm going to put my division bar, and now I'm going to work downstairs. I've got 1 minus, well, pi over 6 is root 3 over 3 times pi over 4 is 1. Okay, so I have this ugly, ugly, ugly looking fraction. Let me make that smaller. It's okay. I'm going to work just in the numerator for a second. Root 3 over 3 plus 1 is 3 times 1 is 3 plus root 3. So I have 3 plus root 3 back over the common denominator. So 3 plus root 3 back over the common denominator in the numerator over 1 minus root 3 over 3 in the denominator. Now I'm going to clean that denominator up. So the numerator is going to stay the same for now. And by the way, do not cancel those. Bad algebra, okay? This will be 3 minus root 3 over 3. So now I want to clean this mess up. I have the numerator, which we leave alone. So I'm going to rewrite the numerator, and we're going to We're going to multiply. So we're going to change division to multiplication, and now we're going to flip this, right? We're going to take the reciprocal of the denominator, and these 3's are going to cancel. So what I'm left with is whatever's on the top in the numerator, 3 plus root 3. And whatever's in the bottom, which is 3 minus root 3. Now for this test, technically you'd have to multiply up and down by the conjugate. I'm not going to have you do that for this test. If you end up with something like this, just leave it alone. Okay? You're good. So tangents are not the most pleasant thing to work with because there's a lot of stuff involved to get to the final answer. And a lot of it involves fractions, and you've got to be really careful so you don't make a mistake. I'm going to give you another tangent one in a second. Okay, the next thing we use these for is to write expressions for the sine, the cosine, and the tangent. So these are easy because what they're going to do is they're going to give you the expanded form, and what you have to do is recognize that this is the difference formula for the cosine. And how do I know it's the cosine? Because the pattern goes cosine, cosine, sine, sine. So I know it's going to be the cosine. And I know the sign that goes in here is going to be the opposite of what's out here in the expanded form because that's what the cosine does. And then all I have to do is add those and I'm done. Okay, you don't have to find the cosine of 40 or anything like that. They just want you to write the expression. Here's another one. This is going sine cosine plus cosine sine, so I know that's the sine of 140 plus 50 according to the formula. So I'm taking the expanded version, I'm condensing it down, and then I'm just adding those two angles together, and that's it. I'm done. Nothing else to do there. There's another one with a tangent. And again, this looks ugly, but it's not bad, because what do I know? I know that this is the difference formula, because that difference will be here in the, remember this sine matches what's in here for the tangent. So it'll be the tangent of 140 minus 160, or the tangent of negative 20 degrees. Fini. Okay, another way we can find exact values is they're going to give you the sine of an angle and the cosine of an angle, let's say. They could give you any two trig functions, right? Could be anything. And they're going to ask you to find all the rest of the trig functions, the sine, the, u plus v, u minus v, whatever. Okay, so what you want to do is for whatever u they give you, whether it's sine, cosine, or whatever, make a u triangle, right? Triangle with an angle u. And the sine is the opposite over the hypotenuse, so fill those in and then use Pythagorean theorem to find the missing side. And then you're going to do the same thing with the angle v. You're going to make a right triangle. Cosine is opposite over adjacent, so, adjacent over hypotenuse. So you're going to plug those in, use Pythagorean theorem to find the missing side. And at this point, you want to remember that where your angles are. So this is telling you that they're both in quadrant 2. So what do I know? I know that the sine is positive in quadrant 2 and the cosine is negative. That means my tangents are going to be negative, right? The secant is going to be negative, the cosecant is going to be positive, and so forth. But rather than that, what they want you to find is the sine of u plus v. Okay, well the sine of u plus v has this formula. Sine u cos v plus cos u sine v, right? So all I have to do is reference those triangles. Try and fix this. Hi, Ella. Ella's coming to do math. She's bored. She wants to play. Oh, you want to play, poor puppy.
Okay, I'll play with you in just a minute. Just a minute.
So, anyway, this is our formula, and now I'm going to use my triangles to plug in. So I have the sine of u. Well, the sine of angle u is opposite over hypotenuse. It's positive in quadrant 2, so I plugged in a 5/13. Times the cosine of v. Well, the cosine of v was already given as negative 3/5, so I just popped that in there. Brought down the sine. The cosine of u is 12/13, but remember, this is in quadrant 2. And so the cosine is negative in quadrant 2. And this is negative 2, I forgot my negative. And the sine of v is opposite over hypotenuse, and it's positive in quadrant 2. So now when I multiply these together, I'm going to get negative 15 over 65 and negative 48 over 65. And since the signs are the same, the denominator, right, has the same common denominator, so I can write one denominator. The signs are the same, so we add and keep the same sign. So I know the result is going to be negative. 8 and 5 is 13, carry the 1, so it looks like negative 63 over 65. Right? Then they want you for the same set of triangles, so I don't know if I'm going to be able to fit them in here. I'm not. Then they want the cosine of u minus v. So real quick over to the side here, I'll make a little u triangle, which was 12, 5, 13. And a little v triangle, which was 3, 4, 5. Okay? Just so you can see. So the cosine of u minus v is the cosine u cosine v plus sine u sine v, right? I'm being bad tonight. It's too late. I'm too tired. Anyway, the cosine is negative in quadrant 2, so cosine is adjacent over hypotenuse, so it's negative 12/13. The cosine of v was given, so I popped that in. The sine of u is 5/13, and the sine of v is 4/5. Again, both of those are negative in quadrant 2. So what I'm going to have here is negative 12 times negative 3 is a positive 36 over 65, plus 20 over 65 is going to give me 56 over 65. Now let's do the tangent. The tangent of u plus v. So this looks pretty ugly here. My handwriting's not doing well because I'm tired. But u plus v means I plus here minus here for the tangent, right? Tan u tan v over 1 minus tan u tan v. I'm going to try and get those little triangles in the picture here. So the tangent of u is 5 over 12, and I have to make sure it's negative because it's in quadrant 2, and the sine is positive and the cosine is negative, so the tangent is negative. Okay? Plus tangent of v, well, the tangent is 4/3, and again I assigned a negative to it because it's in quadrant 2, over 1 minus tan u tan v. Again, I made them both negative because they're in quadrant 2. Now, what I did from here to here is I multiplied this fraction by 4 over 4, an equivalent fraction, so my denominators would be the same. So here I have 5 over 12 negative plus negative 16 over 12, right? And on the bottom, I have 1 minus. Now, a negative times a negative is going to become a positive, so I get 20 over 36. And if I clean up the top, I can add and keep the same signs for the numerator, so I get negative 21 over 12. And on the bottom, I get 36 minus 20, which is 16, back over that common denominator, which is 36. So it's starting to look better. And then, if you remember, we're going to take the numerator and we leave it the same. Okay, so here it is. I've got it kind of crossed out, but I'll do it over here again. Okay, so I'm going to leave the numerator alone. I'm going to change this division bar to multiplication, and I'm going to flip this bottom fraction. And what I can do is cross multiply. 12 goes into itself once, and it goes into 36 3 times. So what I'm left with is negative 21 times 3, which is negative 63, over 1 times 16 is 16. Okay, and that's what I have over there. Alright, but I just didn't know if you would be able to see that on the film. Alright, and that's it for section 5.4.